This is lesson 7.3 special right triangles. Today we're looking at 45, 45, 90 triangles. Now if we have a 45, 45, 90 triangle, we have two angles that are both 45, which means their side lengths are both going to be the same as well, which means x equals 5 because the other side length, the other leg is across from 45 is 5. Okay, solving this by the Pythag method. I'm going to go through this quickly because you already know how to do this. Now, I'm not expecting you to solve it this way because there's actually a much quicker way to solve it. But if we solve a squared plus b squared equals c squared, we'll get y equals 5 radical 2. Okay, let's see one more example of this. We know the other leg across from 45 will also be 2. So 2 squared plus 2 squared equals b. If we solve for b, we get radical 4 times radical 2, which simplifies to 2 radical 2. Okay, but here's the important part. Every 45, 45, 90 has the same relationship. Across from the 45 is a 1, across from the other 45 is a 2, and across from the 90 is a square root 2. So that's the relationship of every 45, 45, 90. Now remember, every 30, 60, 90 was a 1, root 3, 2. So this one is a 1 to root 2. We can set up this problem the same that we set up the 30, 60, 90 problems, and that includes drawing a similar triangle. Okay, so if we draw a similar triangle with side lengths 1, 1, and root 2, we would have 6 over 1 equals x over root 2. We cross multiply, we get 6 root 2 equals x. So x equals 6 root 2. Let's look at the setup of two more. Set up our similar triangle first with our ratio of 1, 1, and square root 2. Well, we automatically know that y is 6 because it's across from the other 45. So it has to be the same as the other leg. So y has to equal 6. All right, but now to solve for x, we have 6 over 1 equals x, the hypotenuse, over root 2, the hypotenuse of the similar triangle. If we cross and multiply those, we get 6 root 2 equals x. All right, looking at example 5. Starting with our similar triangle, our 1, 1, and root 2, we have x over 1 equals root 2, the hypotenuse, over a similar hypotenuse, root 2. Cross multiply. X times root 2 equals 1 times 8 root 2, which is just 8 root 2. Divide both sides by square root 2, so we can get x by itself. And we have x equals just 8 because the square root 2's cancel. Even more so than in the 30, 60, 90 triangle, shortcuts are really helpful in a 45, 45, 90 triangle. If we're going from side length 1 to side length 2, we're just multiplying by root 2. If we're going from hypotenuse to a leg, we divide by root 2. So you either have to remember to multiply by root 2 or divide by root 2. In example 6, we're going from the hypotenuse to the side, which means we're dividing by root 2. So 10, the hypotenuse, divided by root 2 will give me x. Well, I have to multiply both the top and the bottom by root 2 to rationalize the denominator. My final answer will be 10 root 2 over 2. That equals x. Well, x is the same thing as y, so we don't even have to do it again. I just know that 10 root 2 over 2 equals y. Let's get down these last two examples. We know that y is going to be the same as 4 root 5 because they're both across from the 45-degree angle. So we really didn't have to do any math to figure that out. As for x, we're going from a leg to a hypotenuse, which means we're multiplying by root 2. Okay, so x equals 4 root 5 times root 2. Remember, if it's inside the square roots, they multiply each other. So x equals 4 root 10. Now we're going from a hypotenuse to a leg, so we divide by square root 2. So 6 divided by square root 2 equals x. Multiply both the top and the bottom by square root 2 like we did last time to rationalize the denominator, and our final answer is 6 root 2 over 2 equals x. And 6 over 2 simplifies to 3 radical 2. There we have x. 3 radical 2 is also equal to y because they are both legs of a 45, 45, 90 triangle.